So here we go. So the triangle inequality conjecture. Whoops, I don't want to do that. I'm going to make a straight line. And I'm going to not make it dotted. So here's a line. Here's another line. Hey. And here's another side. Okay. If I try to make this reach, it won't reach, right? And so this one plus this one, in order to make a triangle, that one plus that one have to stretch. Let's see. Whoops. That didn't work very well. Let's try that again. If I take this, does this stretch it? Can I stretch it and turn it or something? So this side, can I move it? Ooh, there we go. Okay. So in order for three sides of a triangle to make a triangle, the sum of any two sides has to be greater than the third side. Okay. So that's what it should say. In isosceles triangle, not an isosceles triangle, the sum of the lengths of any two triangles needs to be bigger than the length of the third side. Okay? So, for example, what if I give you a problem on a quiz, and I say, can 3, 3, and 8 be the sides of a triangle? What do you think? Why not?
Because 3 plus 3 is not.
Because 3 plus 3 is less than 8. How about 4 plus 4, 4, and 8? Could that make a triangle? No, because 4 plus 4 equals 8. So then I would just have like a straight line and two sides that didn't quite reach, right? How about 7, 8, 9? Because he was hungry, right? 7, 8, 9. Yes, because this plus this is bigger than this. This plus this is bigger than this. You have to check all three sides. Okay. So let's try one more. Yes, this works. And then lastly, how about 1, 8, and 5? What do you think of that?
Yep.
Who says yes? Why no? Because 1 plus 5 is less than 8. So those two sides, right, if I have one side that's 8, those two sides are not going to reach, right? So you have to check, even though 1 plus 8 is bigger than 5, you have to check all three combinations. There's three possible things that you have to check. So that one doesn't work. The other thing you might see is, you might see a problem like this. If given 3 and 5 are the lengths of two sides in a triangle. Oh, that's me. I can't answer the phone right now. From Indiana.
I'll answer it for
No,
you.
I know.
It's on speakerphone. I'll
I know
answer
it
it.
is.
Might be offering.
Given 3 and 5 are the lengths of two sides of a triangle. Find the range of lengths for the other side. Okay? So this is a little bit, you'll see one like this on a quiz, and people always get this one wrong. So it might be a good one. It might be a good one to talk. Did I say range? Find the range. So from what to what can that other side be? What is that other side? What about 3 plus 5?
8.
Okay, 3, so they have to be
7. That's lower than 8.
3 plus 5, 8. 3 plus 5 has to be, so it has to be less than 8, right? You understand that? Because if I add those two together, the biggest that side could be is 8. How about the smallest that other side could be?
Wait, so it has to be less than 8.
It has to be, it
No,
can't,
the lowest can be 2.
it can't be 8 because 3 plus 5, 3 plus 5. Why is the lowest it could be 2? That's correct.
Because 3 plus.
3 plus 5, 3 plus 2 equals 5.
So that's supposed to be 3.
Yeah.
Because 2 would be equal, not greater.
Yeah, so it'd be 3. That's a little bit bigger.
It has to be a little bit, so like what, 2.1 here?
Couldn't be 2 point.
No, isn't it 0.0000?
Can't be 2.
Anything
It's
above
3.
2.
So how would you write that?
Oh, yeah, that was.
You could write it like this, okay? This means S is got, not, yeah. So S has got to be bigger than, S has got to be less than 8 and bigger than 2, okay? Think of it this way, okay? So here's your side that's 5. Here's your side that's 3, right? Okay? So if this thing is any bigger than 8, are those two sides going to reach?
No.
No, okay, so it helps to draw a picture of it. Okay, now watch this. Here's my 5 piece. Here's my 3 piece over here, okay? 3. How long does this piece have to be, at least, in order for it to reach this side? It has to be at least 2. Do you understand that?
Above 2.
Okay, so,
It can't be 2.
Because last time you took.
yeah, that's what this says. Side,
But you
okay?
Yeah. Yes, at least.
At least 2, more than 2, very good, okay? So the side has to be bigger than the difference, this is the difference, and less than the sum. Do you get it? Okay, you might want to add that to that conjecture, the triangle inequality conjecture, because people out, and don't write like, it's got to be bigger than, or don't write like 2.9 or something. Anything bigger than 2, because what's bigger than 2? You know, 3 is bigger than 2, but so is 2.000000001, right? Would that work? Can I decide that's 2.0000? Yes? It could be, the side would have to be bigger than 2, so 2.00001 would work, right? And would 7.999999 work here? So you can't just say like 7.9. So how do you remember on the last quiz? There was some question like that. And you rounded it off or something and it didn't come out. Oh, show that a supplementary angle, if you divide it in half, it has to be less than 90 degrees. Remember that one? And what you guys did, you said, well, 179 is, so if I divide 179 in half. So what you needed to do is take x is less than 180, so x over 2 would be less than 90, you see. So you had to do some, you don't want to write like actual numbers in there, so a lot of you guys messed up on that. So given 3 and 5, that should say given. All right, so you understand that problem? You're okay with that? Okay. It also happens that if you have a triangle, which you will, you'll have lots of triangles in this chapter, and in the interest of time, I'm just going to draw a funny looking triangle. It's not that funny looking, but here's a triangle, okay? It so happens that if this side is like, say, 20 degrees, and this side, say, is 100 degrees, this side has to be 60 degrees. It turns out that which side appears to be the biggest?
The biggest one.
The biggest one, okay? So A, which is the next biggest? B and C. So there's another triangle inequality thing, and that's C21. It says side angle inequality. In a triangle, if one side is longer than another side, then the angle opposite the longer side is longer than the angle opposite the shorter side. I don't know. I would just think of it this way. The longest side is opposite the biggest angle. The shortest side is opposite the smallest angle. And the middle side is opposite the middlest angle. Okay? So they'll say like order the lengths of the side, lengths of sides from smallest to biggest. Could you do that? What's the length of the sides from smallest to biggest? C, then B, then A. Okay, that's all. From smallest to biggest. C, B, A. That's all you have to do. Okay?
Wait, for,
They can do, and it works the opposite. It works the same way for angles. Okay, so say I draw a triangle, and I go, oh, let's use my triangle drawing tool.
Yeah.
I like that. Okay. So say this side is 8.
Hold up. Mine didn't do that.
This side is 9. And this side is 11. Okay. A, B, C. Okay. Arrange the angles. Arrange the angles.
Smallest angle.
Angles from, and be careful of the question because people get this wrong too. Because I'll say one question, I'll say from smallest to biggest, and I'll say biggest to smallest. Okay. So which is the biggest angle on this picture? Raise your hand. Okay, raise your hand. Yes, John.
A.
A. What's next, John?
C.
And what's next?
B.
Is that hard?
John.
Is that
That's
hard?
excruciating.
Okay, it does get tricky though, okay? For example, say I have something that looks like this. I'm gonna try that. Oh, let me get my triangle shape drawing tool again, okay? So here, 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 okay? And I'm going to draw another one here and here. See if that makes a triangle. That one, oh, did that make a triangle? Kind of, okay? So, say I tell you that this is 30 degrees. This is 100 degrees over here. This angle over here is 100 degrees. Whoa. And this side over here is 35, or this angle right here is 35 degrees. And I call this A, B, B, C, D, and E. And I say arrange the sides. So it becomes a little more complicated.
C counts as a side.
the B and C are the same.
Okay, so here we go. This problem is not that evident. I would kind of write down, please, take some notes or something. Okay, pay attention. Don't you ever take notes? You know how to do it? Okay, so this says 35 right here. Okay, what does this angle up here have to be? Can you guys tell me?
50.
Very good. That angle's 50. So the first thing I would do is fill in all the angles. That's 50. You can tell me what this angle has to be right here. 45. Okay. So do you guys want to figure this out, or do you want me to help you? Okay. Within this triangle right here, which is the biggest? Which is the biggest? So let's go biggest first. B is the biggest. Then what does it go? Then A. Then what? C. Then within this triangle here, okay, what's the biggest side? C. Then what?
E.
E. And then what? D. Okay. So how can I arrange these from biggest
Box it.
down, or smallest down to biggest? Who thinks that? But C is the biggest, right? Why shouldn't C be the biggest, or should B be the biggest?
B is the biggest.
Why?
Right.
Because of it.
See, C is the smallest in this triangle, right? And if I look at this triangle, but it's the biggest in this triangle. See that? So C comes before, C is bigger. Let's just change this. Yeah, let's just change it from biggest to smallest. Okay? Biggest to small. And you could always flip it around, right? So the biggest one. Okay, so in any case, so So to go from biggest to smallest, this is the biggest side. The next biggest side would be this. This is the biggest side of this triangle, but it's bigger than, it's the smallest side of this triangle, but it's bigger than these two. So to range it from biggest to smallest, I would go B, then A, then C, then E, then D. Got it? You get that? That difficult for you? All right.
Why do
All
I
right.
see twice on the top?
Because first I was looking at this triangle, and then I was looking at this triangle. All right. The next thing in this chapter is called the exterior angle theorem. Exterior angle. It's on your little sheet there. Exterior angle conjecture. They used to call these theorems before they called them conjectures, so we're calling them exterior angle conjecture. So in a triangle, say you have a picture that looks like this, and this is 50, and this is 100, and they say find x over here. Who can tell me how to do that? I know you can figure it out. Go ahead, Sophia.
Well, you do the triangle, so it'd be 30, because it has to equal 180.
Okay, so this angle is 30.
Yeah, and then you have to, the other one would be 150, because that has to equal
180 minus 30 equals
150.
150. Very good. Now there's a shorter way to do that. Okay, see how she took, that's what I wanted you to do. There's 2 steps to do it. Okay, but there's a shorter way to do it. Yes, sir.
Like, see, there's like a 50 on that left side.
Yeah.
Like, minus that, like, minus 180. Wait, what?
The 50 plus 100.
Yeah, that's what I meant.
50 plus 100.
Way to go.
What about 50 plus 100?
What about
Equals
150?
50.
It equals
It's
this.
X.
Now, there's an algebraic reason that that's true. Okay, so you notice that maybe if I add those two, if I add these 2 pieces together, maybe I get this one. You would probably have to try to make sure that works. Like do inductive reasoning and try that a couple times and make sure it works. But you can algebraically prove that that's true. Say I call this A, this B, and this C, and say I call this D. What's true about A plus B plus C? Those equal 180. Okay? What's true about A plus B? Equals 180. So if A plus B equals 180 and A plus B plus C also equals 180, what can I say about A plus B plus C and A plus D? They're equal. Okay, so I could write a little equation. A plus B plus C equals A plus D. What do I have in both sides of the equation? A, so I can subtract an A from both sides. See that? So I get that B plus C equals D. Okay, which is just what I said. That these 2 angles have to add to the 3rd angle. And that's, so what I just did, I noticed something was true using inductive reasoning, then I just proved that it was true using deductive reasoning. And that's what you do a lot in geometry. This is a little algebraic, geometric proof that I just did. I didn't state the reasons, I did everything. So that's the exterior angle conjecture, which is on your sheet, and it says triangle exterior angle. The measures of an exterior angle of a triangle is equal to the sum of the measures of those things. These 2 angles have a name, okay? Over here, okay? These are called the remote. Remote, what does remote mean?
Then it changes the channels.
Yeah, what? You know why it's called the remote?
The 2 buttons.
Because, hey, when I these 2 angles, the remote interior angles, are the angles that are far away from the exterior angle, not the ones right next to each other. That's why they're called remote. All right, because they're far away, just like you can stand at your remote control. You know, now you're like, you can't get off the couch, you know, to get in your remote. Okay, C21, isn't that what it said? Oh, side angle inequality.
It's longer.
And one side is longer than the other side, then the angle opposite the longer side is longer than the angle opposite the, no, it's opposite the longer side is longer than the angle opposite the shorter side. Yeah, that's right. Okay? So then we can apply this to different situations. So say for instance, I have a triangle like this. Whoops. And by the way, this one here, sometimes you'll have triangles that look like this with a little tail on it, like a fish. Okay? The exterior angle is this one or this one, not this one in between. Okay? So it's what you get from extending one of the sides with a side of the triangle, not this angle right here. So both of those angles are the same because those are vertical angles. So say for instance I tell you that this angle is 145 and this angle here, let's see, up top is 65. And I say, even though it doesn't look like it, not to scale, not to scale. How much would this angle over here have to be? How much would that angle have to be? Using what I just learned, without adding up to 180 and doing all that stuff, what would that have to be? 80 degrees, right? Because you know that this plus this has to equal that, right? So that equal, or I can subtract 65 from 145 and I get 80, all right? Okay, and then lastly, you might see one with some algebra in it, okay, which we like to do algebra, right? You like to do algebra, right, kids?
I love algebra.
No, good. That's what you should say. Very nice. All right. So algebra. So here's one. I'm going to draw this a little bit differently. Let me try again. Okay. Draw a triangle. Draw this triangle. Make it go like this. Make it go like kind of backwards like this. All right. And I'm going to tell you that this angle here is 5x minus 10. And that this is x, and that this is x plus 5. And I say find all the angles or something like that. Could you do that?
Yeah.
Who can give me an equation to find all the angles? Go ahead, Sarah.
X plus 5 equals 5x.
X plus 5, you probably in parentheses, equals 5x minus 10. Right? Good. Ooh, is this going to work? Might, maybe. Let's see if it works. Does it work? 2x. Yeah, it works. 2x plus 5 equals 5x minus 10. Now what I do? Add 10 to both sides. So I'm going to add 10 to both sides, plus 10, plus 10. Okay, you got to follow the algebraic steps. 5x equals 2x plus 15. Then what?
Minus 2x.
Minus 2x, minus 2x, minus 2x. 3x equals 15. What's x equal to? X equals 5. I think we're about done. So you can see that we saw this equation. Hopefully you learned something. Let's homework is page 218, 1 through 16 all. Okay, I think there's